All right, guys, welcome back. Now we're going to move on from simplifying radicals, from adding and subtracting radicals, to multiplying radicals. So we're going to multiply radicals. Okay. Multiplying radicals far and away has the fewest rules. So I, take that as a little bit of exciting news. We don't have to do all of this pre-work in order to get a solution. So multiplying radicals, most kids think it's probably the easiest, just because there's some tricks that we don't have to worry about, right? How adding and subtracting, we had to worry, are they like terms? Multiplying radicals, they don't have to be like terms. You can just multiply. Just like you could multiply 3x times 10x squared. To do this problem, we can just multiply these. They aren't like terms, so we couldn't add them, but we can multiply them. We get 30x to the third. So the rules for multiplying just regular variables work for multiplying radicals with one little twist at the end. So step one is multiply the coefficients. Right? Just like in 3x times 10x squared, we multiplied 3 times 10 to get 30. Now we're going to multiply the radicands. Just like up here we did x to the first times x squared makes x to the third. The difference is this is our final answer for a variable. We do still have to take our answer and simplify. So we're going to have to simplify. We just simplify at the end instead of simplifying at the beginning and then simplifying at the end. So let's start basics, right? Let's start the easiest problem. So radical 3 times radical 6. Multiply the coefficients. Well, the coefficient is 1. The coefficient is 1. So 1 times 1 is 1. I don't have to write it. Multiply the radicands. 3 times 6 makes radical 18. Now I do need to simplify. So if I take my factor squares and I look at 18, 3 and 6, I'm not going to use those because those aren't perfect. But 2 and 9, 9 is perfect. Square root of 9 is 3, so I'm going to break it down. This part can be skipped. Right? You don't have to rewrite 2 times 9. Some of you are going to want to. I encourage you right at the beginning when you're practicing, when you're first learning this, to write this step down, just so that you don't make a mistake. But the square root of 9 is 3, leaving behind radical 2. And you're done. So let's throw a few variables in there just to make things interesting. So we have 3 radical 4x times 4 radical 8x to the third. Same rules. So 3 radical 4x times 4 radical 8x to the third. Same 3 rules as this first problem. 1, multiply the coefficients. So 3 times 4 is 12. Multiply the radicals, or the radicands. So 4x times 8x to the third. 4 times 8 is 32. X to the first times x to the third is x to the fourth. We can't leave that as our answer, though. We have to remember step 3 is to simplify. So I'm going to leave it 12, and I'm going to take radical, and I'm going to go to my factor squares, and I'm going to look at 32. I could use 4 and 8, but I'm not going to use 4 and 8 because 2 and 16 is better because 16 is a bigger perfect square. So 2 times 16, and I'm going to leave x to the 4th because it's even. The square root of 16 is 4, so that comes out, so it's 12 times 4. I can also do the square root of x to the 4th. How many pairs are in x to the 4th? So 4 divided by 2 is x squared, and it leaves behind a lonely 2. I'm going to keep simplifying. 12 times 4, 12 times 4 is 48, x squared radical 2. All right, so what if it looks a little different? What if it looks like this? 5 radical 3 squared. Before you panic, remember 5 radical 3 squared is just 5 radical 3 times 5 radical 3. I mean, it's nothing to be scared of. Just expand it. When in doubt, write it out. So again, we follow the rules, multiply the coefficients. So 5 times 5 is 25. Radical, 3 times 3 is 9. Oh, radical 9 works. I don't even have to go to my factor. It's a perfect square. So that's really 25 times 3, which is 75. All right, let's take it one notch up a little bit. Let's do radical 3n times 2 radical 4n squared times radical 12n. Why not? All right, I'm just going to do this left to right. I'm going to throw in my coefficient because sometimes that makes me less nervous. I'm going to cover up this second one. I'm just going to go step by step. Can you do it all at once? Sure, you could do it all at once. We're going to go step by step just so that you see it in your notes. So 1 times 2 is 2 radical. And again, remember, I'm forgetting that one. 3n times 4n squared is 12n to the 3rd. I have that third one, so I'm just going to put it at the end. All right, let's keep going. So multiply the coefficients. So 2 times 1 is 2. Radical 12 times 12 is 144. N to the 3rd times n is n to the 4th. Oh wait, I can do radical 144. The square root of 144 is 12, so 2 times 12. And since this is even, how many pairs are in 4? How many pairs am I going to get out of it? Well, 4 divided by 2 is squared. So everything underneath that radical got simplified. So 2 times 12 is 24n squared. And multiply the coefficients, multiply the radicands, simplify. All right, let's go back a little bit in our memory. What if I had 2 times the quantity, radical 4, or radical 2 times the quantity, radical 4 minus 5? You may be thinking to yourself, what are you doing, lady? But remember, like if this was just 2 parentheses x minus 5, how would you do this problem? You'd distribute. So radical 2 times radical 4, multiply the coefficient. There are no coefficients, 1 and 1, so that doesn't multiply the radicands. So 2 times 4, radical 8. Then I go over here, my coefficient is 1, right? So I'm going to go to the next one. Ooh, remember that that's really a -5. It's not 5, it's -5. So that's a coefficient. So 1 times -5 is -5. And the radicand, radical 2 times, there is nothing, so radical 2. I'm not done. Multiply the coefficients, multiply the radicands, simplify. So I'm going to look at radical 8. I'm going to look at 8. Oh, I've got one. Radical 4. So 2 times 4. So 2 times 4 minus 5 radical 2. Square root of 4 works, so I bring out a 2, leaving behind a radical 2 minus 5 radical 2. Oh, now I can even simplify this more because they have the same radicands. They're like radicands. So 2 minus 5 is -3 radical 2. All right, so we distributed. Let's take it a little bit further. What do we do to this problem? 2 plus radical 2 times 5 plus radical 2. So we've got a binomial, right? 2 terms times a binomial, 2 terms. Ooh, remember this trick? FOIL, first, outside, inside, last. So first, I'm going to write this out. So 2 times 5. First times first, that's 10. Outside, that was 2 times radical 2. 2 times radical 2 is 2 radical 2. I is inside, so that's radical 2 times 5, which is 5 radical 2, right? Multiply the coefficients. 1 times 5 is 5. Multiply the radicands. Radical 2 times no radical, right? So radical 2. Okay, and L is last. So radical 2 times radical 2, which is radical 4. Ooh, I can simplify that to make it 2. So my problem is now 10 plus 2 radical 2 plus 5 radical 2 plus 2. Can anything be combined? Oh, yeah. 10 plus 2 is 12. And 2 radical 2 plus 5 radical 2, that works, is 7 radical 2. So let's do one more. Let's see, x radical 3 minus radical y. 4 radical, let's see, 12 plus 3 radical y. Yikes, what was I thinking? Okay, here we go. First, outside, inside, last. All right, first, x radical 3 times 4 radical 12. So x times 4 is 4x. And 3 times 12 is 36. Outside, x times 3 is 3x. 3 times y is 3y. Inside, -1 times 4 is -4. Y times 12 is 12y. -1 times 3 is -3. And y times y is y squared. All right, let's simplify. Okay, 36. Let's go to 36. 2 and 18, no. 3 and 12, no. 4 and 9, that's potential. Or I could do 6 and 6. Which one should I do? 4 and 9 or 6 and 6? 6 and 6, because you guys, we don't want anything left behind. Square root of 36 is perfect. I can get rid of it totally, making it 4x times 6, which is 24x. Can 3x radical 3y, can 3y be simplified? No. 3x radical 3y, I'm done. Okay, let's go here. Yeah, that can work. Negative 4 radical, okay, 12. 2 and 6, or 3 and 4? 3 and 4. 3 times 4y. Radical 4 is actually 2, so negative 4 times 2 is negative 8. Radical 3y. And down here, can radical 6y be simplified? Yeah, because it's even, so I divide by 2, making it negative 3y. Let's put them all together. 24x plus, because it's positive, 3x radical 3y minus 8 radical 3y minus 3y. Can these two go together? No. Their radicands are the same, but their coefficients are not like terms. So this whole thing is your answer. This is a challenge problem. You're not going to see this on your homework, but you may see it, you know, as extra credit somewhere along the line. Hint, hint.